Do you recall the statement, write the equation of the line in Math 100? Well, this is exactly what you're doing when given the following. Write the linear function f, for which f of 1 equals 3 and f of 4 equals 0. All right, so what you used to hear, the terminology you used to hear before pre-cal was write the equation of the line. It means exactly as write the linear function f in pre-cal. We just changed the lingo a little bit. All right, here's how you find or write the linear function, given some information. You first identify the points that were given to you. This is how you get the points from this information right here. So if I ask you, what is the point that corresponds to f of 1 equals 3, what would you say?
1 and 3.
Yep, 1, 3. All right, someone else, if I ask you for the point that corresponds to f of 4, f of 4 equals 0, you would say
4 and
4
0.
0.
4, 0. That's it. All right, that's step 1. Identify the points. Step 2, find the slope. How do we find the slope of 2 points? Somebody?
Use the slope
Slope
formula.
formula.
There you go. That's why I asked you to memorize the slope formula. All right. Can someone tell me what the slope formula is?
It's m equal y squared minus y
Not y squared. Not y squared.
by 2.
Y sub 2.
What's up
So,
to?
yeah, this is what I'm saying. Y sub 2. What does sub stand for, anybody?
Subscript.
Subscript. Thank you. Now, if it was a superscript, don't put superscripts because in math, those are called what?
Exponents.
Exponents. Exponents mean something totally different from subscripts because exponents mean multiplied times itself. That's a whole math operation. So you don't want to confuse superscripts with subscripts in math. Subscripts are just labels or you're naming a number. That's all you're doing. All right. Next thing I want y'all to do is let's go ahead and say label your points. So label your points as x sub 1, y sub 1. All that means, that subscript means this is the first set of points. And then we have x sub 2, y sub 2. This is the second set of points. That's all that's saying. All right. So tell me, in my formula, my slope formula, what should I put in the numerator right now? Y sub 2 minus y sub 1 is
0 minus 3.
0 minus 3.
0. Yeah, 0 minus 3. All right, divided by,
4
what about x sub 2? You said 4 minus
1.
1. Thank you. And 0 minus 3 is
Negative 3
negative 3 divided by,
over 3.
which equals
1.
Negative 1.
negative 1. All right, this is our slope. All right, that's step 2. Step 3, put this information into the blank formula. Anybody know what other formula that I required you to learn or memorize?
The
that
slope
you need?
intercept.
Was it the slope intercept or was it something else?
Was it the point slope formula?
Point slope formula. All right. Point. We're gonna put it in the point slope formula. Can someone tell me what the point slope formula is?
It's y minus y sub 1 is equal to
All right.
m parentheses x minus x sub 1 parentheses.
Very nice. Very nice. All right. So we're gonna put the information that we have into this formula. We don't put anything for the regular y in the regular x. We are replacing, though, we're replacing the y sub 1 with what? So y minus, what's y sub 1?
3.
3. All right. Equals, we are replacing the m
With the
with
negative
what?
one.
Negative 1, because m here is negative 1. All right. Times x minus x of 1 is
1.
all right, 1. Very nice. Then we have y minus 3 equals, we need to clean up the right side. So what we need to do to the right side?
Are you gonna multiply the 1 times the x minus 1?
Negative 1, right?
Oh, yes, ma'am.
All right, we are distributing. Yes. So negative 1, tell me what to write when we distribute.
Negative 1x plus 1.
Negative x plus 1. Very nice. What do you think our goal is right now? What are we trying to do?
Get x by itself.
Not get x by itself,
Get
Is
y
get
by
y by itself.
get y by itself. So let's get y by itself, because we want it in the slope intercept form. All right, because we want the answer in slope intercept form. So what would you have to do?
Add 3 to both sides.
Add 3 to both sides. Add 3, and then we get what? Y equals
Negative x plus 4.
negative x plus 4. Very nice. Now, since the question was write the linear function f, we need to change that y to a what?
F of x.
F of x. So f of x equals negative x plus 4. And I already put a graph of negative x plus 4 already on your notes here. So notice that those points 1, 3, 1, 3 that we started with and 4, 0 are on the line of that function. That's how you can prove that that function is correct. If you put your function here in Desmos and those points actually cross that line. Right back through these steps right here. Step 1 is identify the points. All right, identify the points. So I want you to tell me, based off of this information right here, what are the points?
Negative 4 and 6, and 4 and negative 9.
Do it again. Do it again. I think you said it wrong, but I know you know what you're talking about.
Oh,
The
negative
points.
2 and 6,
Uh-huh.
and 4 and negative 9.
Yep. All right. Those are our points. That's our x and our y for the first equation and the x and y for the second one. All right. Step 2. Let's go back to it. Step 2. Find the slope. What do you need to find the slope? Anybody got your notes out?
The slope formula.
Yep. M equals, can somebody tell me what it is?
Y2 minus Y1
Uh-huh.
over X squared minus X1.
All right. You got to say it right though. X sub 2. Y sub 2 minus y
Yeah,
sub 1. All
my
right.
bad.
Because there's a difference between this and this. Isn't that a major difference? So it does not equal each other. All right. One is a subscript. That's why we say SUB, X sub 2. And one is an exponent. Exponent means something totally different. It means, for example, x squared multiply x times itself. All right. Subscripts don't mean anything mathematically. It's just like naming a number. The next thing I want you to do is identify what x of 1 is, y of 1, x of 2, and y of 2. Again, that's just naming the numbers, x of 1, y of 1. That's just saying this is the first set of points, and this is the second set of points. All right? So y of 2 equals what?
-9.
All right, then put minus y sub 1 equals,
6.
all
6,
right, divided by x sub 2 equals,
4 minus
4,
-2.
all right, 4 minus -2, good. So in the numerator, what's -9 minus 6?
-15,
-15.
Yep, 4 minus a -2 equals
6.
6. Can I reduce this fraction?
No.
yes,
Yes,
How?
you
How?
can. 3.
you can,
3
yeah,
Divided by 3.
divided by 3. 3 goes into 15 how many times?
5.
Yep, and 6?
2.
2,
All right, so what we really have is -5/2. All of this means the same. So you wrote it like that, it means the same thing. Just don't put the negative in the denominator. All right, step 3, what we're going to do, put this information into the what formula? What formula we got to put this information into? What formula do we use now?
The point slope formula.
Thank you. The point slope formula is, what is it?
It's y minus
Uh-huh.
y sub 1 equals
Mm-hmm.
m. And then gonna put parentheses x minus x of 1.
All right. So that's just m times x minus x of 1. So what we're going to do, we're going to replace the y of 1, the m, and the x of 1. All right. We want the regular y to remain. So y minus what's y of 1?
6,
6 equals what's m?
-5 over 2.
Yep. We just came up with m. M is our slope. X minus what's x of 1?
-2.
-2,
Yep. Yep. So that's why I could make this a bracket, because we got a parenthesis on the inside. All right. Someone other than Kenneth and Christina, tell me, what would you work on next? What would you work on?
You're gonna distribute.
All right. One person said distribute. Give me something else.
Get rid of the fraction.
You
Try to
could do
get
that.
y by itself.
We definitely want to get y by itself, but that is our goal. That is our goal, to get y by itself. But what simplification I want you all to do first, you think?
What's in the bracket?
What's in the bracket? Yes, if you said that, yes, what's inside of this bracket, that's what I want y'all to work on. Because if you don't, you're probably gonna get it wrong. Okay, so you need to put y minus 6 equals -5/2 times x. What else?
Plus 2.
6 plus 2.
Yes. Please do that first. Please change that minus negative to a plus. All right. Now, I think Alicia, you really did. You said get rid of fraction. I think that's an awesome idea, but most people will probably distribute right now, and that's fine too. Yep. So both ways are great. So let's go ahead and distribute the right side. So I'm gonna put this up here. Y minus 6 equals. We got negative 5 halves times x. That little first part is negative 5 halves x. All right. You're a real champ if you know what the next one is. So if you multiply negative 5 halves times 2, what do you get?
-5.
Negative 5. Yeah.
Well, I'm very impressed. Negative 5 is correct because the 2's cancel out. All right. Now, yes, our goal is to get y by itself. So what would you do next? We're not
Add the 6.
done yet. Yep. Add the 6 to both sides. That cancels. Y equals negative 5 halves x. What else?
+1.
Yep. Last step. Last step. Anybody remember last step? So I don't have to show it to see if y'all remember. What's the
Change
last
the
step?
y to f of x.
Very nice. We just changed because they said write a linear function. So we just write the notation for function, which is f of x. Well, it really said write the linear function f. So it's even telling me they want it to be f. They don't want it to be g of x or h of x, for example. All right. I say by next week, know the general shapes of the following functions. The 8 graphs shown below represent the most commonly used functions in algebra. You have this first one. What do y'all, okay, this is called the constant function. So what do you think the C stands for?
Y.
This C right here, what do you think, why do you think they named it C instead of another letter?
Constant.
Or
Constant.
constant. What is a constant in math? What is a constant? What does that mean?
Like a
What is
number.
a number? Yep. It's just a number. Like f of x equals 1. F of x right here, it looks like it might be like 1.3 or something. So C might be 1.3 or something like that. All right. The next one. This one right here is f of x equals x. It's called the identity functions, but I don't really use that term a lot. For both of these, I use the term linear function. Linear function. Okay. All right. The next function is an absolute value function. If you had to describe it, how does it look? It looks like a what?
A V.
A V. So the absolute value function always looks like a V. These are linear. Obviously, they're going to look like a line. All right. This one is the square root function. If you had to describe it, how would you describe that?
A single curve.
A single curve. Okay. I like it. Let's go down to this one. F of x equals x squared. It's called a quadratic function. Sometimes they call it squaring function. I don't use the term squaring function a lot. I use quadratic function a lot more than squaring function. I hardly ever use squaring. All right. It looks like a what if you had to describe it?
Parabola.
Which is, maybe somebody doesn't know what that is. What's the shape? If
A
you had
U.
to describe, a U. If you had to describe it to a middle schooler, what's the shape? U, a U. All right. What's the degree? What's the degree of this function?
2.
All right. So if the degree is 2, y'all know it's gonna look like a U. If the degree is 1, what is it gonna look like?
A line.
A line. All
Oh,
right.
yeah.
Now moving on to cubic function. Degree of 3. How would you describe this one?
Mm,
I know, right? I call it like a little snake or something. A little snake. All right. All right. Then we have the reciprocal function. We're not going to do a lot of reciprocal function. You may see it some, but this is a reciprocal function. Notice it's a fraction, 1 over x. And then the greatest integer function. I hardly even touch this function. So usually I don't test you on this greatest integer function. All right. It's really used mostly for probably computer science majors. It's probably mostly connected to. All right. Fill in the blank. I want you all to make sure you make this change because I think I made a mistake on here. Fill in the blank. It should say the constant and identity functions are a special type of function called linear functions. So change the, I think it's either this one or this one, change it to constant and identity. I think I put linear up there, I think. All right. All right. So if you have the old notes, it's not updated. I just updated it last week. All right. Familiarity with the basic characteristics of these simple graphs will help you analyze the shapes of more complicated graphs. In particular, graphs obtained from these graphs by the rigid and non-rigid transformations. So on Thursday, we're probably going to do more of something called transformations. Go ahead and try to get familiar with the shapes of these parent functions they call. They call them parent functions. Because on Thursday, we might start talking about the children of these functions. And I want to show you how they're related to the parent function. All right. What we're going to do for the next 10 minutes is just graph. We're going to go back to our graphing days. See if you remember how to graph, okay? Let's review these functions. F of x equals x squared because I want you to see how it obtained its shape, all right? So I'm going to be a little extra here. I'm going to do my little table. Normally for a t-table, you put x and what?
Y.
Y. Yep, you usually put x and y. Since we're dealing with functions, what do y'all think I'm going to probably put?
F.
F of x, yep. And I might be a little bit more extra and extend my graph all the way like this. All right. Tell me, what's the name of this graph?
Quadratic.
Quadratic. It looks like a what?
A U.
A U.
Very good. Very good. It looks like a U. It's not a line, so I might need more than 2 points, okay? What points y'all want to plug in to this function?
-2.
All right. So I'm going to, since you said -2, I'm going to -2, -1, 0, 1, and 2. That's what I'm going to do. All right, let's plug in -2. F of -2 equals -2 squared. What's -2 squared?
4.
4.
Very good. So what would be the point that corresponds to this information?
-2 and 4.
Very nice. Let's plug in -1. That would be -1 squared. What's -1 squared?
1.
1, thank you. So what point corresponds to this information?
-1 and 1.
Yep. Let's plug in a 0. 0 squared. This is my contribution. That's just 0. So it'll be 0, 0. What about F of 1? That's 1 squared, which is 1. So what's the point that corresponds to this information?
1 and 1.
1 and 1.
Yep. F of 2 equals 2 squared, which is 4. What point corresponds to this information?
2, 4.
2, 4. All right, what we're going to do is plot these points now. I'm at the origin. Where would I go to plot -2, 4?
The left twice.
Yep.
And then you go up 4.
Yep. 2, 3, 4. Right here. I'm not gonna label them right now. I'm just gonna plot them. Negative 1, 1. Negative 1, 1. Where should I go here? Negative
Negative
1, 1.
1 on the x-axis.
Go to the left. One
And
Go to
up.
the left.
One.
Okay. And up. All right. 0, 0. I'm gonna go ahead and just put that right there. 0, 0. 1, 1.
Go to the
Right.
right and up one.
All right. And 2, 4.
Go to the right twice and up 4.
Yep. Y'all see how it's now you said it's gonna look like a what again when we get done? A U. So since we know what it looks like, you need to make sure that you kind of curving your graph. Okay, a little bit like that. All right. It should not look like a V. It should look like a U. All right. So that's how it gets its shape. If I ask you right now, what's the domain? What would you say of this graph?
negative infinity to positive infinity.
Very good. Someone other than Kenneth. What would you say was the range of this graph? Hmm.
0 to positive infinity.
Very good, Mary. Is there a parenthesis or bracket on the 0?
Bracket.
Very nice. So for domain and range, you do think about parentheses and brackets, but for increasing, decreasing, and constant, you do not think about that. You just plainly put parentheses for all of it, for increasing, decreasing, and constant. All right, let's see, can we graph one more for today? What is this function called for B?
Cubic.
Cube
Very
function.
nice. All right, how would you describe how it's gonna look? How does it look? The cubic
Like a
function.
snake.
Yep, it's gonna be something like whiny like that. So let's figure out how it gets its shape. I'm gonna use negative 2, negative 1, 0, 1, and 2 again. All right, we're gonna evaluate this function at negative 2. So f of negative 2 equals negative 2 cubed. What is negative 2 cubed?
-8.
Negative 8.
Yep. So the corresponding point would be,
-2, -8.
yep, sure is. All right, negative 1, f of negative 1 equals negative 1 cubed. Negative 1 cubed is,
-1.
yep, the point is,
-1, -1.
yep. All right, my contribution is f of 0. 0 cubed is 0, and so that's 0, 0. All right, f of 1 equals 1 cubed, which equals,
1.
and the point,
1,
1,
1.
1.
yep. And f of 2 equals 2 cubed, which equals
8.
8. So the point is
2, 8.
2, 8.
2, 8. Yep. All right. So let's plot the points. We're at the origin. Where should we go to plot negative 2, negative 8?
Go to the left 2 times. Down 8.
All right, left 2, and then we're 8.
Down 8.
Yep. Yep. 1, 2, 3, 4, 5, 6, 7, 8. All right. What about negative 1, negative 1, 1?
It's supposed to be -1, -1.
Oh, sure is. I don't know. And y'all see my mind was like negative 1 for some reason. Tells me it's negative 1, negative 1. All right. Negative 1, negative 1. Where do I go?
Go to the left 1. Down 1.
All right. All right. 0, 0. That's my contribution. 1, 1.
To the right 1. Up 1.
Yep. And 2A.
To the right 2 times up 8.
1, 2, 3, 4, 5, 6, 7, 8. All right. Again, since you know what the shape is gonna be, you're gonna try to make it do that. Okay. You're not gonna make a line straight line because you know that it curves somewhere in the middle. So it's curving right there. All right. I don't think we have time to do the next one, but you do see that C is a what type of function?
Square root
Square
function.
Square root. And how it's gonna look?
That's a curve, a single curve.
Something like that. And then D is a what type of function?
Linear.
Linear. Specifically, it's a, give me something more specific than that.
Constant.
Constant. Very good. We'll get to that next time. But if you want to stay around, ask me questions. I think I want